Today's topic is the battle against disease. Now, we're going to talk about mRNA vaccines. Okay. So, if you're up for it, it's a kind of short and sweet little video telling you the basics about the mRNA vaccines. Okay. So, what is happening now is that bacteria, pathogens, virus, they are getting more and more drug resistant. Okay. And you can see that many people have to take one level of antibiotics, and sometimes it doesn't work. So they have to go to a higher range and it keeps going up. Okay. And sometimes you reach the seventh antibiotic, which is the seventh level. And that's the last that is available in the market, which you can get. And the eighth one is under lock and key. It's unreleased. And this is mankind's last defense against any kind of serious disease that might come along. Now, even during COVID, they did not release this because they found that this was not something that was going to actually stop the virus. The chances were very low. And even if that drug did get out, that's the end of it. Because if some other bacteria happens to get resistant to it, then mankind is going to be at a, kind of a very, very dangerous situation. So rather than bring out, get efficacy against battling these diseases that come along, what they did was they experimentally introduced the mRNA vaccine. Okay. Now, is this a curse or a boon? Okay. Now, the research for the mRNA vaccines go back as far as the 1900s. And this theory was thought of very, very long ago. But it's only become more and more practical now because, technology has come in and stepped in and done some good stuff for us. Okay. So how does this actually work? Now, what's this big thing about how this mRNA that really works, and what does it do? So it first used very recently to fight against COVID-19. Of course, highly experimental, tested, did what they could and released it. Okay. So what is it exactly? It's a type of molecule. Okay. It's a strand of, let's say, a virus DNA, not the whole virus, but a part of it. And it has the ability to deliver a set of instructions to your cell. Now, your cell, what it does is, it starts to manufacture antibodies. Okay. Now, so the mRNA goes and sits on, by a whole process, goes and sits on your cell wall, and the cell immediately reacts. Okay. And it says, okay, there's something wrong here. Okay. And by itself, this mRNA tech, as you call it, it uses a viral protein. They call it a viral protein because it's part of the signature of let's say, a virus. Okay. And so what it does is it kind of simulates an infection. Okay. You really won't get infected, but it will simulate the infection. So they use a protein wrapper so that when the virus, so that it enables the virus to get into your body. As you know, proteins are something that the body will just naturally, let it go through because it's kind of a food. Okay. So it attaches itself to the cell wall, and that protein starts to replicate and spread. Okay. So it's kind of like a pseudo virus by itself. And then after it's deployed itself, it starts to break down very quickly. It doesn't stay in your system for long. It starts to break down. So what happens is the cell learns how to defend itself against a brand new virus. Okay, because the protein structure is different. So the body learns. So what the mRNA is doing is actually, it's like somebody coming in with a disguise. Okay. Looks like the real thing, but it isn't the real thing. Okay. And then the cells used to say, okay, I'm reacting, because that's a natural biological reaction. Okay. And so what happens is the body starts to create a kind of a defense against, if the real virus or the real bacteria, whatever comes into your system, it already has some kind of idea how to identify it and what antibodies to start creating. Okay, so it's just a part of the real virus. So every time you have a new virus, they have to actually develop a new mRNA vaccine. Okay, now there is no one glove fits all. Okay, just one. You have to keep developing different kinds of mRNA vaccines for different kinds of diseases. Okay, and you'll never get infected because it's not the true virus by itself. And like I said, it starts to break down almost immediately. It does multiply for some time, and then after some time, it has a shelf life. So they just hope that there's enough mRNA vaccine in your blood so that it can kind of infect quite a few cells, and the cells start to learn. So you don't have to teach every cell in the body. A few cells start to get it. Few cells will be probably 100,000, 200,000, I guess. And but here's a big problem. Will the virus adapt to mRNAs? So it's quite possible that the virus will adapt against the antibody. And it really depends on how complicated or how simple the virus is. If the virus is very simple in its structure, its ability to change becomes more possible. So viruses, when they first get introduced into the human system, and if they're very simple, when you attack them with drugs, what happens is it starts to adapt, and it keeps adapting. And you would have seen in what had happened with COVID, it started to mutate. Okay, and they started giving it all kinds of names, all kind of Transformer movie names, Omicron and whatever. So I know they're very funny names that they gave them, but the virus adapts. Now, at one stage, the virus will become so complicated that it becomes more vulnerable because it's very simple. If you have more moving parts in a system, the chances of failure are more. So the same thing happens to a virus because its chain starts to get more and more complicated. There are more and more breaking points. Okay. Now, why does the virus actually tend to adapt? After a while, the virus learns that if it is killing the host, then it's going to run out of food. So it finds a way to start evolving so that it can have a kind of a symbiotic relationship with the host. So while it may infect and eat and try to survive and multiply, it will slowly adapt into not trying to kill the host. I mean, that's generally the way the evolution of a virus. Okay, so it tries not to, but trying not to may take a very long time. Okay, and meanwhile, you'll die, and the virus will probably escape from your body again. It'll go out, it'll infect another host. It'll probably have some information. It'll start to adapt. But when you introduce the mRNA into the system, it's a kind of an artificial adaptation that the virus has to take care of. Okay, something is not going to recognize that, oh gosh, I'm a new boy in town, but the guy already knows who I am. That's because of the mRNA vaccine. Okay, so even before you've been exposed to it, it already has a way to battle it. So you're kind of pushing the virus into another kind of mutation. Okay. So, however, the success and everything, there have been side effects of these mRNA vaccines. Now, what are those problems that have come up? There have been heart problems, circulatory issues. One patient even got paralysis. Okay, and this is all the results of what came through in the COVID when they had the host of these mRNA vaccines, and there were a lot of cases that did come up. Some are very severe, and sometimes they don't occur immediately. Sometimes they happen after you've taken a booster. The first shot might have gone well. 3 weeks later, take a booster. Then probably a month later, suddenly something happens to you. And I think we do know, they do suspect. Okay, I don't want to point any fingers, but we lost a great leg spinner to a heart attack, and they're kind of saying it is probably a reaction to one of the mRNA vaccines that you've taken. So this technology definitely has a lot of promise. Okay, but there has to be more research, because when this gets into your system, we don't know whether that strand of DNA, with the body will think it's from its own memory. Okay, the body has its own memory when it's trying to fight viruses and diseases that you would have picked up over the years, and genetically you will have some defense. Now, putting that all together, what might really happen is you might get a kind of an allergic reaction to it, or the body will think that something else is happening. So, so a lot of these things happen. You might get inflammation of your veins, and a lot of things might happen, and they don't happen in all cases, but they can. There's a chance that it can. So they have to do a lot more extensive research, and the problem is that only a few people get. Not everyone in the population gets it, so it's hard for them to actually pinpoint what exactly it is, because it could be because of that person's history. It could be because he might be taking some other kind of a drug. Maybe he's eating some kind of food that actually reacts, and this combination, this cocktail actually makes wreaks havoc suddenly. Okay, so the body can be extremely sensitive, and it can be overactive in terms of its defense. And as you get older, the amount of memory your defense system has is immense. And the body will start thinking that maybe a food is a pathogen or a bacteria, and you get a kind of an allergy. And allergies are mainly because the body thinks that it's something deadly because it resembles a virus. One part of it might resemble a virus or a bacteria, and it is going to attack it. And very similarly, a very acute case is cancer, where the body turns on healthy cells and starts to kill them. So a lot of, there is a lot of more tech which is not just mRNA, but they're finding other components in food, certain acids that are available in certain foods that could actually break down the virus or the bacteria from multiplying. It kind of like sterilizes them, so to say. Okay, family planning for the bacteria and viruses, you might want to call it. So at the end of the day, when there are serious things like Ebola and things that you don't really have a cure, and so Ebola, for example, is once you get it, it's almost you're certain to die. So in such cases where death is inevitable, then what you got to do? Yeah, maybe then it's a chance that you can administer an mRNA vaccine. So probably the world was very excited initially, and they thought, wow, this is now the new wonder. But as these cases started to come up and people were having bad reactions, not so sensational anymore, because I think there's a lot more advancement that needs to be done in this area. And for now, I think they are going to probably focus mRNA against things that are very, very difficult to stop. Like tuberculosis has reached a point where they're all drug resistant, Ebola and things like that. A lot of diseases that are kind of, chances are that you'll have it terminally or very chronic. So that's the focus for mRNA vaccines. And like I tell everyone, eat at the right time and with the right nutrients. Okay. So if you follow the dynamic vitality model, simple, it guards you against these opportunistic ailments. And in fact, it'll guard you against even new viruses that might come out because your body is strong. Okay. And strength is not just muscle. Strength is in your entire metabolism, because your body is tired and doesn't have the fuel to fight back. You can fall sick with just a cold and a cough, right? So I hope you enjoyed today's topic, and I'll open this up for any questions that you might have.